In today's video, we're going to start looking at how we work with lists. We've previously looked at things like how to use the append method, the index method, and min and max, and all those types of things, but how do we really use lists? Well, let's look at some examples of how you can use lists and where your list can kind of get you in trouble if you're not careful. So here we have an example. And this is not a list, you might notice. I just have x equal to 5, and I set y equal to x. And then I'm going to print out those values, and then I'm going to say that x equals 13 and print those two values again. And you might go, well, why are we doing this? This should be obvious. Well, let's just run this real quick so we can see. In our first set of print statements, we have x equals 5, y equals 5. In the second set, x equals 13 and y equals 5, just as you would expect. Now, the question is, what happens when we do this with a list? So I have here a list of 1, 2, and 3, and then I set y equal to x. Notice that everything is almost identical to what we saw in our previous example. The only difference is that now we're working with list. Let's run this application real quick and see what happens. Notice that in my first example, I get 1, 2, and 3 for both x and y. And then after I change one element in x, notice that my lists are the same. So instead of copying the data like it does with a primitive data type, it actually creates a reference to that list. That's because a list could be very, very large, and it needs to be fast and efficient. So how do we get around that? Let's go back to our source code real quick, and I'll show you a quick little trick. I'm going to create an empty list, and an empty list is just square brackets. And then I'm going to say plus. Now, we've done this before, but I want to show you what happens now. Let's rerun that last script again, now with our modified. And you'll notice that what happens is when I make a modification to one element in list X, list Y is not changed. That's because even though we just had an empty list, it concatenated two lists and create a new list for us. So if I need to duplicate a list instead of just getting a copy to it, this is one easy way to do it. Now let's say I need to find the sum of a list. So here we have a list of numbers, and we have a total, which starts at 0. This is going to be our running total, and we're going to loop through our list, get the value of each individual element, and add that to our running total. Once we do this, we can print out a sum of our list. When we run our file, we get 48. If I bring up the calculator and add, you'll notice that we get the exact same value. This is what we're hoping for. This is what we're looking for. And this becomes really beneficial if I have to work, especially with a large list. With a small list, I can enter it into a calculator. But if I'm dealing with potentially hundreds or thousands of numbers, then I don't want to have to manually enter this into a calculator. I'd much rather use a program like this. Now, you might ask, what about getting an average? If I can get the sum, well, getting the average is really easy. So all I'm going to do is I'm going to change my print statement to say the average of the list is, and then take my total and divide it by the length, or if you want to think of it, the size of my list. The total divided by the number of elements is going to give me the average. So if I switch over here and I run my list file, notice that my sum is the same and my average is 8.0, which is what you would expect for this value. 6 elements, 48 divided by 6 is going to be 8. Now, I may need to provide finding the total and the average quite often for my list. Well, I can pass a list to a function. So here I've created two functions, one to find my total of my list, and the other to find the average. Notice I take a parameter in both of these functions. In this case, these functions are expecting my parameter to be a list. In my function total, I'm going to run through my list just as I did before and return the value of my total. For average, I'm actually going to pass in my parameter to total so I can get that value. And then I'm going to divide it to find the average. This way, I'm not duplicating my work. This follows that dry principle of do not repeat yourself. I do not need to create several lines of code in order to gather my total when I have a function that will already do it for me. This just makes it faster and easier for me to develop my code. Let's just see how this is going to work. I've added 2 print statements, and what I'm going to do is I'm going to call my total function and then pass numbers to it. Likewise, instead of getting the total and then returning my numbers, I'm going to call average in order to do this. I'm going to save this, and then let's run this and see if we get the same results. You notice that both results are exactly the same. This is what we expect. But by creating some functions, we have the ability to call these functions time and time again, simplifying our process and making it much easier in the long term to write an application. And these are some basic ways that we can work with lists in Python. Whether it's finding totals and averages, using it with functions, or duplicating their values in a variety of ways. All this information will help you write your Python programs easier when you're using lists.